Hi, in this video we'll be going through the basics of debugging. This is where we can dive in and learn some actual strategies for debugging student code. Debugging is a process we use to fix bugs or problems that find their way into our programs as we develop them. Debugging is the most important skill your students will learn in this course. Debugging requires problem solving, critical thinking, and creativity. And we want students to get to the point where they can learn to ask the right questions and solve their own problems. The debugging process starts when something is broken or isn't working as intended. We create a hypothesis about what is wrong and why. Then we try to fix it. If we make the fix and our program now works, then we're done. But if we try a fix and the program is still broken, we return to step 2 and try again. Oftentimes when we are debugging, it can feel a lot like Where's Waldo, where we're looking for this small detail, this one thing that's out of place in this large program. We're going to learn some strategies to help us simplify the landscape and really narrow in on where the problem might be occurring, so we can isolate that bug and find Waldo. We have 3 strategies we're going to focus on. First, we want to write readable code, because when we can read our code, it's much easier to debug. Second, we'll look at attention to detail. Programming requires us to be extremely explicit, meaning that even a missing punctuation mark can cause an error. And third, we'll dive into questioning assumptions. Sometimes we think there couldn't possibly be something wrong with one aspect of our code, so we overlook it, when that is actually where the problem exists. So how can we write readable code? It can look a little different depending on the language you're programming in, but overall, there are some general techniques for all languages. First, there are comments. Every programming language has a way for you to insert comments, that is, text within the program that will not be executed. In these, we write out in our own words in plain language what we intend the program to do. That way, when we're debugging, we can look at the comment and ask ourselves if the code matches up with what the comment says I intended the code to do. Next, we need to have proper indentation in our programs. Having proper indentation helps visualize the structure of the code, so we can see which code belongs in which function, for loop, while loop, and so on. The editors we will use often build in the indentation when we type the text. Lastly, we should use proper naming so that the names of our functions and variables describe exactly what they do. We don't want functions named myFunction, but rather functions like readTemperature. If the names are clear, we can look at the program and ask if the function is doing what the name says it should. The next strategy is attention to detail. We need to get the details exactly right. Computers are very picky, and the syntax needs to be perfect. It's very easy for things to slip by, so we need to keep our eyes peeled for small errors such as typos in variable names and syntax errors in functions, if statements, and loops. Every little detail can impact what our code does and doesn't do. The last strategy is questioning our assumptions. A big realization that every programmer needs to make at some point is that the computer isn't making a mistake. It's doing exactly what you told it to do. It's tempting to hold on to the idea that your program is right and there's just something wrong with the computer, but that's not true because the computer does not have the ability to go rogue. The computer only does what you tell it to do. So if something is going wrong, it's on us to see where we messed up. This means we may have overlooked something. Maybe we misread the problem description. Maybe our pre and post conditions are not correct. Does this function actually do what we think it does? What have we assumed works that could actually be broken? We need to question our assumptions and look at our own work to see what could be wrong. In this lesson, you'll explore these strategies to practice debugging sample programs. Let's go.